Geographically, we are located 40 kilometers south Brussels in a small town called Jean-Blou. For the last 25 years, we are 10 people working full-time in NIR. And beside that, we have also the wet chemistry for all the reference, what's probably 20-25 people more. I started in 1981 when he bought the first instruments. It was a Neotech 51, and I did the first calibration then using this very new instrument, probably one of the first in Europe. And then I never quit. I'm participating in the NIR International Conference, and at the top of it I will be probably the next chairman for the International Committee of Near Infrared Spectroscopy. NIR is fast, cheap, and also environmentally very good because there is no need for reagents, so that's very ecological technique. We can measure all kinds of products you can imagine in agriculture or any organic method, from soil, but also of course plants and byproducts and waste, everything you can imagine. Regarding the number of samples and the information we get over the years, we have the information from the 80s in the data set, so we kept this information stable and valuable for the 25 years. There is probably very few people able to provide so huge data set on the same product. The in-gut calibration comes from several years ago when we decided to merge our data set with ONIR. I've been contacted by Chris Pietrowski, and we decided to merge our effort and our databases to create this product called in-gut and to promote the use of this large and wide calibration worldwide. I think the relationship is very good with ONIR. They are doing all the commercial parts, so they promote the in-gut calibration, they have the contact with the users, the end users. We are doing the technical parts, transfer calibration and updating and providing calibration on request. We need calibration with NIR because the relationship between the matter and the light is specific by product, so you need to calibrate for each commodity. To calibrate, we need a reference method, and here in the lab we have most of the reference methods accredited by Bellac in Belgium. We have also the NIR accredited, so we can make both. Reference method accredited, good calibration or good validation, and accreditation of the NIR too. We have quite a lot of different instruments, so one sample is measured several times when you have a reference to include in the data sets.
I'm responsible for the lab of analytical chemistry and technology. So this is mainly reference methods, classical chemical methods, and these methods are very often rather heavy, so they are often used to calibrate more rapid techniques like mid-infrared or near-infrared.
We are here in the main NIR lab, the main development laboratories for the in-gut products, and in partnership with the ONIR in-gut in UK, but that's here that we develop most of the data sets and the calibration for the in-gut product. In-gut can run on all the machines, but of course we focus on the main brands for the moment. In the lab there is more than 12 instruments here for NIR in different brands, and that's part of our job in the ONIR collaboration. That's to transfer the data set from basically on this instrument to the other brands.
How to transfer the calibrations, because it's not very easy. Each instruments are very different. Software different. The programmation is different, so we need to create a program to develop the models. The data set I have, it's 130,000 samples. So we have developed some software to select the best samples in this big data set. We update all the calibrations when the customer wants to have new models with his own samples. We add the samples to the calibrations and we rebuild a new one and we send the calibrations to the customer.
We can develop the calibration for any kind of instruments, providing they have the same wavelength coverage, of course, like this one, which is a portable one. Say the calibration for flour directly in the plastic bag, and we just shot here, and it's done. You have moisture, protein, star damage, water absorption, and ash. That's very quick. At this stage it's a research, but if someone needs a calibration for this, for flour, it's available. The advantage is quite obvious because we have huge data sets available to provide very robust calibration. If a user is without calibration and if he has to start from scratch, he will need a huge sum of money and a lot of time and a lot of effort to rebuild something similar. In my opinion, that the calibration is never completely finished. It's always possible to find new information and to improve something in it. The future of the technology would go probably more online and probably more portable, but we will need also this transferability as well to not be obliged to redevelop calibration each time. So the transferring between brands is important, and that's what we are doing here.